Hello, I'm Michael Dorin. I teach software engineering for the University of St. Thomas in St. Paul, Minnesota. I worked professionally in software development for nearly 30 years before starting a teaching career. I also do research with Dr. Sergio Montenegro of the University of Würzburg in Würzburg, Germany. The focus of our research relates to bugs, the ramification of bugs, and identifying potentially buggy code. So why is the study of ethics of software important? Software affects people's lives in one way or another. The impact may be large or small. It might be just wasting your time, or it might have major ramifications to your health or your financial situation. So one question to think about then is, what does the creation of software have to do with unethical behavior? Then if you assume the creation of software it does have a connection to ethics, and the creation of buggy code also has a connection to ethics, how do we teach software engineering ethics, and how do we teach software engineering students regarding ethics? All right, so where do we begin? What do we have to start with? 40% of students in undergraduate or graduate school admit to plagiarism. And an even more interesting study showed that computer science students were especially likely to plagiarize. As a professor of software engineering, I remember sending students out to do data structures or simulation projects. And the first thing that they would do is go to the internet to see if a project had already had a solution. I even had one student ask me where I found my problem because they could find it nowhere on the internet. Ethics issues in software began in the 1960s when software started to have a prominent part in our lives. In the 60s, the systems were basically sequestered and you needed physical access to it. But that didn't stop programmers from deliberately doing bad things. And it didn't stop even bugs from causing havoc with us. For example, presently it doesn't seem to be quite as important to be balancing our checkbooks, but for a long time there was enough computer errors that balancing our checkbooks was a very important part of receiving a statement each month. The 1960s deliberate bad behavior revolved around people creating fake employees or robbing fractional cents from interest payments on check and savings accounts. In the 70s, software became to be more pervasive and connectivity became easier and easier to attain. Things like stealing long distance service became popular, but also people were breaking in. Acoustic couplers were available and people were breaking in to things like trucking and railroad sites and having shipments diverted to where they could be more easily stolen. Much of the problems still were that much of the ethical dilemmas of the time still were in the domain of simply the common criminal. And our common criminal gets even more uncommon now, more sophisticated. Madoff and his software people created a system that deliberately misled people to believe that their retirement accounts were actually growing and safe, at the same time siphoning off billions of dollars from individuals. Madoff and the software people deliberately use their software skills and their skills to defraud people. But we still have examples of unethical behavior not deliberately done, leading to impacts on people's lives. So for my purposes, as a starting off point for teaching software engineering, I have arrived at 4 types of ethical lapses. And these ethical lapses were derived from people who have more formally studied philosophy and ethics than I have, but I've divided it up into 4 camps. And the reason I do this is in software engineering, we teach things like coupling and cohesion. And we teach students to know more about coupling and cohesion than simply a module has to be highly cohesive and low coupling. We teach students how to identify different types of of cohesion, different types of issues of cohesion and coupling. And my perspective is we should have the same philosophy with ethics. We should teach the students some classifications of ethics so they can easier identify when ethical lapses occur. So for example, lapse of attempted tolerance happen when an act is justified by not wanting to offend anybody. And we can see that just in meetings, for example. We might not speak up when something incorrect is stated in a meeting just because we don't want to offend somebody and want the meeting to end. Or the same could be applied to the status quo. We just sit there and follow the status quo to continue. Lapse of conscience are the easiest ones. This happens when ethical act is known to be wrong. And then overconfidence is another one. This is a little bit harder to pin down in the software engineering perspective, because as software engineers, we do want to stretch our skill set. But still, if we're in a situation where people could be harmed and we're stretching our skill set, we should recognize that we might have some overconfidence and take some steps to alleviate the overconfidence, the dangers of overconfidence. So, for example, I believe that the famous case of the Theric 25 is definitely a demonstration of overconfidence bias. It's reported that much of the software source code was written by one author, and it's reported that there wasn't adequate documentation that the author of the code had actually tested the code to make sure that it met the requirements needed for performing radiation therapy. So from my perspective, this is easy to attribute to overconfidence bias. Another thing that was reported is that the organization that made the device did not have very well-defined software process. And this was something that was common during the day. So basically, this is sort of even though they were making a device that could potentially harm people and did harm people, they basically followed the status quo of software development practices of the time. So this is another ethical lapse, whether deliberate or not. They were following the status quo of how other organizations develop software. And aviation systems. There's several aviation accidents. I'm going to briefly touch on the Chinook helicopter. I also suggest this could be a lapse of attempted tolerance or a status quo because of the bureaucratic nature involved with this accident and the investigation of the accident. That things weren't resolved as quickly as possible because of the bureaucracies. So we might attribute this to lapse of attempted tolerance or status quo. And of course, the famous 737 MAX, there's probably a lot of ethical issues to be considered here. But first and foremost, I want to say I still want to give Boeing the benefit of the doubt that even from the sense of good business, I don't believe that they would knowingly send a plane out that was going to kill passengers and be destroyed, an expensive plane that's just simply not going to be good for business. But I do believe they certainly showed some overconfidence bias with their systems, and some overconfidence bias by letting the planes fly when by all rights they should have been brought in. There's arguments that lapse of conscience had happened and some other lapses. So there's definitely a lot of investigation, but the Boeing accidents are definitely a fertile ground for ethical lapses. And space exploration, definitely another overconfidence bias was the failure of the Ariane 5. Which the reason they suggest it's overconfidence was they used software that came from the Ariane 4, which had been proven correct on the Ariane 4, so they were confident that it was going to be proper on the new system, but the new system presented a new environment, and with the new environment, it wasn't proven, and hence causing the problem. I don't have any specific examples in nuclear energy, but I think that we can all agree if there is an accident in nuclear energy related to software and ethical dilemmas in software, it would certainly be a bad day for everybody. But back to the importance of ethics in software, back to the crux of the matter. The reason thinking about ethics is important boils down to situational judgment. Situational judgment is the action that you're going to do based on a given situation. So suppose that we have the different types of ethical lapses memorized and we can identify them. My feeling is that if software engineers can identify potential ethical lapse, the situational judgment, taking the correct action in a situation, is likely going to be easier if you've thought of the different types of ethical lapses ahead of time. And I have to believe, for example, the engineers for Volkswagen, they were pushed to the limits. The technology wasn't quite there. They were probably working day and night. They probably became numb, and they probably wanted to get the problem overcame. And of course, there's even more examples. This is an excellent book, but basically talks about projects that participants feel are destined to fail, and they obviously didn't feel they were destined to fail in the beginning, or they wouldn't have started. But you get to the point in a project that maybe the technology is too far, or the requirements are too vague or too difficult, that the project just never seems to finish. And so the project goes on and on. The long hours go on and on. Missing the family goes on and on. Stress goes on and on, or health problems go on and on. And this is where understanding where ethical lapses causing problems can be important. If you can identify what could be going on in the stressful situations and make the right decision when you're in the position where you just want the problem to stop. And finally, ethical engineering ethics have been around for a long time. I personally like this one from the early 1900s, the paramountcy clause, where that directed engineers to concern themselves with the health, safety, and welfare of those who are affected by their work. I think that if we can teach the ethical issues and this clause to software engineers, I think the quality will improve. And finally, it's difficult to prove that ethical lapses can truly cause software problems, but it's also difficult in life to find examples where unethical behavior leads to something positive. Thank you very much for watching my presentation, and have a good day. All right, hello everybody. Welcome to my presentation on ethical lapses and complicated software. I'm Michael Dorin, and I teach software engineering at the University of St. Thomas in St. Paul, Minnesota. Before I was a teacher, I worked professionally in software development for nearly 30 years and came across many opportunities to express ethical judgment. I'm presently doing research with Dr. Sergio Montenegro of the University of Würzburg in Würzburg, Germany. And the focus of our research relates to the ramifications and working with buggy software. In this project, as I've worked my way through what seems like millions of lines of code and reviewing millions of projects seemingly, it seems that the coding rules are not adequate to maintain quality software. There's something a bit more that's required. And I think that's where ethics plays a role. I also find that it's an interesting topic to teach to my students, software engineering ethics as software engineering. Software is an important part of all our lives. And lastly, before I continue, I'd like to thank the organizers for the hard work. They obviously put in a ton of hard work to make a nice workshop for today. So I really appreciate that. And I appreciate everybody here who's listening to my presentation. So, surprises in software cause more than an inconvenience. That can change lives. And this, for me, is where ethics come in. So one way or another, software either affects people's lives in a good way or a bad way. The impact may be small or large. For example, if you spend a lot of time playing a game, it might not seem like it has a huge impact on you, even if it's not a gambling game. I think that question came up previously. But depending on how much time you're devoted to that game and how addicting that game is, it can change your life, and it can affect the lives of those who care about you, those who are around you. And software has other ways where it can reach out and touch us even in more physical ways. Since software plays such a prominent role in people's lives, we need to consider that we need to be ethical as we create our software. So in my work, I hope to consider the relation of software problems, the creation of software problems, to unethical behavior. And assuming there is a connection to ethics and buggy code, another thought that comes up is how and what do we do in the teaching of ethics and software engineering regarding ethics? How do we teach it? How do we present it so that our students our software engineering students are ethical enough not to to avoid the creation of buggy code? All right, and while I'm on the topic of teaching, what are the raw materials that we begin with when we're teaching ethics? And this is a study I found quite a while ago, but 40% of students admit to plagiarism in undergraduate or graduate school. And a Stanford study actually showed that computer science students were especially likely to plagiarize. And, so I tease my software engineering students that since it's a software engineering class, of course, they're off the hook, right? Because they're not computer science at that given moment. But seriously, I can see it with the computer science students. I remember giving assignments. I gave one assignment that I created, and a student actually emailed me asking me, where did I find that assignment? Because they can't find it anywhere on the internet. Because in the reality, the students would, as soon as an assignment was given, they would look around, and even the most creative assignments that I would find that I thought that I had was unique about, the students would go out and they would find some other version of it, and they would start with that. They would many students start looking for a solution that already is available rather than starting from scratch. So plagiarism starts early in our discipline. And how about a history of ethical dilemmas before we get too far as well? I'm sure that the ethical problems went further back than the 1960s, but the 1960s is when computer crime sort of came into vogue. Most people didn't have direct access with computers, but there was still some impact. It seemed that programmers who had a little bit of control of accounts or purse strings um, would alter software to benefit themselves and to the disadvantage of the people's accounts that they were tackling. Even though most computers were physically secured at the time, though there was some remote access with acoustic couplers. I don't remember if they came when they probably came in the 60s, but mostly people with software talent made the adjustments, and basically the people with software talent became criminals. So anybody who had access, they might have some temptation of doing something unethical. And then the 70s, things even moved along further. There was more remote access, and there was more opportunity to be unethical. Theft of service from telephone companies was very popular. If you haven't heard the story of Captain Crunch and the whistle for robbing long distance service, it's something that's interesting to read about. But the fact is, somebody had to bend to avoid an ethical dilemma by figuring out how to steal service by using a toy. And then as we move forward, the ethical things really seem to get on steroids. Madoff and his crew actually created systems that would simulate our retirement from being robbed, and they really went to town. It was no longer just we're at the point where it's no longer just robbing fractions of cents or dummy employees. They were literally deliberately going out of their way to steal. So and become common criminals. So for my class, I don't have a formal ethics background. My ethics training came from the undergraduate philosophy class, in their core curriculums when we were young, but it was still important to come up with a basis. So for example, in software engineering, we teach concepts like coupling and cohesion, and students are expected to recognize different aspects of coupling and cohesion. My feeling is that students should be able to recognize different types of ethical dilemmas. So for example, lapse of attempted tolerance being an act justified by not wanting to offend anyone. These are the things that I came up with. I didn't put a lot of formal study in. They sort of came up with come up with empirically and what I've come across. And so there's probably a lot more there's probably more research and probably more detail that can go into these. But I look at these, and then I look at software problems as a way to demonstrate. I look at software problems that have come up, and I apply these, and generally they fit pretty well. Like I say, there's probably room for improvement on them. All right, so let's consider, instead of, up until now, the talk has been on things like computer crime, but how else can software affect us? So we look at one of the earliest problems, and this is probably one of the more famous ones, the Theric-25, a device to administer radiation therapy. And there was problems with it, and people received excessive doses of radiation, and people actually died. Now, in reviewing the case of the Theric-25 and the published documentation, for example, it seems that there was only one main author of it, and it doesn't seem like the main author had a lot of code reviews, and it also doesn't seem like the author had a lot of testing to make sure that everything went well. So this would go back to my overconfidence bias, because there's obviously an illusion of control. I guess I should say, it seems like there's an illusion of control if the author wrote the code independently and didn't have a lot of test or independent review. And it also was, there's some overconfidence as well. I mean, not overconfidence, there's status quo, because the organization it didn't have an established software development lifecycle model, and that's sort of how organizations worked in those days. Another example is an accident of the Chinook helicopter, and I also think perhaps like the status quo fallacy played a role on this, because in reviewing this, trying to determine what the problem was, it seemed like there was a lot of bureaucracy that got in the way. And from my perspective, bureaucracy is like is fertile ground for the status quo. Bureaucracy is sort of a machine that keeps pushing things through. So I think there might have been something to do with that, the status quo. And of course, if we're thinking of aviation issues, we can't forget the 737 MAX. Now, I'm sure that there's more ethical lapses that I give Boeing credit for in this case, but I also want to give them the benefit of the doubt that nobody would knowingly send an aircraft up that they knew was bad. However, I suggest that there's probably some status quo fallacy, because this was an extension of a project, a long-running project, but it was a brand new version of a long-running project. So there was definitely some overconfidence there. And then there's ethical issues with not landing the planes early enough. It could be argued that there was a lapse of conscience within Boeing with their investigation by not grounding the planes earlier. All right, and another example of overconfidence, and it seems like I'm using overconfidence quite a bit in here, but it's just that the summary was this famous accident. This comes up regularly in software engineering textbooks. The European Space Agency, where they used software that was proven correct in an earlier version of the system, and it hadn't been proven correct in the new system. There's obviously some overconfidence here. Otherwise, there would have been a little bit more effort in making sure that the system worked properly in the new system. And the thing is, we can find issues with software problems in all of the industries. So I don't have anything direct. I don't have any direct software problems with the nuclear energy, but we have to admit that it certainly would be a bad day for everybody if software caused a major nuclear accident, and the accident happened because of an ethical dilemma. All right, so the bottom line is we get to the point of what's called situational judgment, at least from my perspective. Situational judgment is the act that you're going to take based on a given situation. And so what I'm getting at is, okay, so these accidents happened. What brought people to get over their quandaries, their ethical quandaries, and actually make some bad decisions with the software? And I'm only going to present one example I mean, one way to get past it, I think about like the Volkswagen clean diesel dilemma, and I gotta believe that the Volkswagen engineers were working day and night trying to get that clean diesel to work, and were getting pretty worn out. And so over time, they sort of became numb to different things, and perhaps even like some test code got out or something, and they decided to go with it. I'm not suggesting that this is what happened, but they decided to go with it just for a few weeks until they got the right thing, because it's probably that the Volkswagen project had become a death march, and the death march is basically a project that eventually the participants believe is destined to fail, and people get worn out. They work constantly, and once you get into the mode where you're working day and night, and like I say, this is just one way I'm thinking that ethical dilemmas can pop up. But once you're working day and night, once you're away from your family, things get very painful, and you just want the pain to stop. And this has happened several times in my career as a software engineer. I even worked for one organization where they put cots into the conference rooms so that we could work until exhaustion set in. When you get to that point, you have to plan out your situational judgment ahead of time so that you know what decision you're going to make. Otherwise, it's easy to um, to make the wrong ethical choice. And so I think software engineering needs an ethical code. I know that ACM and IEEE have codes for software engineering. I like just having this paramountcy clause where it directs engineers to concern themselves with the health, safety, and welfare of those who are affected by their work. That's something that's easy to remember. So in conclusion, it's might be difficult to prove that ethical lapses directly lead to software problems. I have to believe that there's a strong connection to it, and people's lives definitely can be sadly impacted because of the ethical lapses. So engineers do need to concern themselves with health, safety, and welfare of those impacted by their work. All right, and I think that's my 15 minutes. Thank you very much, and let me know if you have any questions.
Perfect, just on time. So thank you very much for your talk. I could relate very well to the experience you had about plagiarism with the students. So please type in your questions, or I don't know, you could try raising your hand if you have any questions. Meanwhile, while the audience is sort of warming up, my question actually, I don't know if there is an answer right now, but as you mentioned, there are different ways in which the ethical lapses could happen. Some might be unintentional, and some might be due to simply the people not being aware that there is a lapse. For example, being overconfident, it is so subjective. I might feel that I'm not overconfident, I am confident, but on not otherwise. I mean, others might not feel the same. So how exactly can these lapses be identified when there is so much subjectivity, and also especially when these lapses could happen unintentionally?
That's an excellent question. I know I'm not supposed to say it's an excellent question, but overconfidence is actually a really good subject, because as software engineers, we also want to push ourselves a bit. So how do we know when we're being overconfident, and how do we know when we're pushing ourselves a little bit, to improve our skills to actually be better? And I think it's something that we have to decide ourselves. If we're getting to the point where we're not completing something, and we've got to the point we're not completing something, or we're not doing something well, and it's something brand new, and I know I'm sort of simplifying the answer a bit, but we have to decide: am I pushing myself too far? On the other side of the coin, it could be I don't want to, because I'm doing the other ethical dilemma of sloth, right? I'm being lazy if I'm not pushing myself harder. So I agree. I don't have a clear answer for you. I think it's harder. I think an organization has to watch out for it. I remember when I was working for Dell, one of the problems that we had, at least in our group, is we would have young people right out of college, and we had to encourage them to come and talk to those of us with gray hair. because they were worried about their confidence that I'm not living up to my what's required of me. So it is something problematic.
Yeah, but I guess now there is a question now, I think, yeah, that you could answer. It's by Jennifer, and she mentioned that software or computer scientists actually are they more likely to plagiarize because there is a possibility to copy and paste code, and should that be penalized? Because in practice, we do copy paste a lot of code. Excellent question, Jennifer.
Yes, and actually, and I actually tell my students, I don't discourage them from going and looking at code, because in real life we get inspired from other people. But I tell my students that if you do get your code, either in my class or in real life, it's not plagiarism if you tell me the source. Now, if you go and you copy a whole program and you give me the source, you're still not going to get any points. But it's not plagiarism at that point if we're acknowledging that somebody else provided it to us. So we can use code, but we do need to give credit to the person who provided it, and we also need to honor the license and the terms that they gave us for using that code.
Yes, I mean, as long as we acknowledge the source and also respect the license, then I think that would not be considered as plagiarism. Yeah.
But as
Um,
I point out, just copying the project and sending it in, even if you give me the source, it's still
yeah.
0 points.
No, no. Yeah, but mentioning the source shows that you are owning up to what you have done, and you would not own up to completely copying something and submitting. Yeah, so that sort of puts some responsibility on the students as well.
Yes.
We have just few more seconds, but I think that was the time we have. So thank you once again, Michael, for excellent talk. And then see you all in the next talk in about 20 seconds.
All right. Thank you very much. I really enjoyed it.